So, the rest of these, the rest of these, characteristics, the y-intercepts and the x-intercepts, which could be called zeros, roots, and solutions. For the parent function, we don't have any. And the reason that we don't have any is because our horizontal asymptote is the x-axis and our vertical asymptote is the y-axis. So this graph right here, your parent function, these two branches never intercept the y-intercept, so we don't have any y-intercepts, and it doesn't ever touch the x-axis, so we don't have any x-intercepts. So we will have y-intercepts and x-intercepts. We will just have to transform it in order to have any. So for purposes of your notes, we're going to write none. If I can get my pen to work. We're going to write none. And this is for the parent function. None and none. Now we are going to transform it. This is the transformation. We do have A, B, C, and D. But the A and the B are going to be kind of wonky this time. C and D are going to do just what they've done all school year long. They're going to shift the not just the branches, but they're also going to shift the asymptotes. So we'll look at some examples of those in just a second. So C and D, C, when C is positive, we're going to shift right. And when C is negative, we're going to shift left. And just like we've done the whole school year long, when you look up here, if C is positive, you're actually going to see an X minus a number because that minus is part of the formula. Just remember that minus, just think of it like this. Whatever you see when you look for C, will be the opposite. That minus sign just acts as an opposite. So just think you're going to be looking for the opposite of C. When you shift your graph left and right, your vertical asymptote should shift with you. Yeah, your vertical asymptote should shift with you. Uh-oh, I'm messing everything up. It shifts with the branches. I'll go over to Desmos in just a second so that you can see everything move. But your vertical asymptote moves. If your vertical asymptote is moving, then what is changing? Your domain. So C changes your domain and your vertical asymptotes. And just like you're expecting, when D is positive, it's going to shift up. And when D is negative, it's going to shift down. And shifting up and down is going to change your range, and it's going to change your horizontal asymptote. So your horizontal asymptote is going to move up and down, and as it moves up and down, your range is changing. So domain and vertical asymptote is changed by C. Change in C causes a change in this. Range and horizontal asymptote, you get it if you have a change in D, then those two change. And then just depending on what your equation looks like will be how you determine what your x and y intercepts. And we'll look at some specific examples in just a second. So I'm going to talk about A and B kind of at the same time. If A is a negative number, you are still going to have a vertical reflection. That means everything that's above the x-axis, like this branch right here, if it's a vertical reflection, this branch will reflect down here. Okay, and then if it's a horizontal, I'm sorry, I didn't finish. And everything that's below the x-axis will reflect up. So That's what happens when A is negative. When B is negative, we get a horizontal reflection. Everything that's on the right side will reflect to the left side. So this one will reflect over here. And then everything that's already on the left side will reflect to the right side. Now, the thing about A and B and this particular problem is that you can't tell the difference between them. The same thing happened with our cubics and our cube roots. You couldn't tell the difference. If all you were doing was looking at the result of the transformations, you couldn't tell if it was a negative A or a negative B. If you're looking at the equation, now you should be able to tell the difference between a negative A and negative B, but the graphs for a negative A and a negative B have the same result. Let's jump over here real quick and see if we can look at that. So here is the parent function that's graphed. We see right here that we have A is 1 and, oh, I have this one turned off. That's why you can't see it. Let me move it to A is 1 and B is 1. And then I'll turn it on so that you can see that they're the same thing. So when A is 1, you get the green graph. When B is 1, you get the black graph. And the parent function is graphed in red. I'm not going to move that one at all. So you can see right here that when A is 1 and when B is 1, you get the same graph as the parent function. So the parent function has an A of 1 and a B of 1. So let's turn them off real quick and let's make A be negative 1. And let's see what it looks like. Okay, there's A being negative 1. What happened right here is that this branch right here reflected down. The Y values went negative, and this branch reflected up. And the result is the green graph. I'm going to turn this one off real quick so you can see the parent function is gone. So that's what having a negative A looks like. Let's turn that off real quick, and let's see what having a negative B with a negative 1. What does that look like? Okay, B is negative 1 now. Let's turn it on. Oh, look, it's the exact same graph, which is what I was trying to tell you just a second ago. You can't tell the difference between a negative A and a negative B because the result is the same. What we did on this case, however, though, we took this right branch right here and it reflected across the y-axis, and this left branch right here reflected across the y-axis and it went to the positive side. So while the reflection, the action was different, the result ended up being the exact same. So if you're just looking at graphs, you will not be able to tell the difference between a negative A and a negative B. If you're looking at an equation, you should be able to see the difference in the negative A and the negative B and where the negative is going to be. If the negative is out in front, it's an A. If the negative is in the bottom with the X value, then it'll be a negative B. But the final result is the same. Okay, so as we considered with other functions like the square root function and the cube root function, when A is greater than 1, we still get a vertical stretch. When B is greater than 1, we have to do the opposite. We get a horizontal compression by a factor of 1 over B. An example of what that would look like is the number A would be a multiplier out in front, just like I have right here, 2 times 1 over X. However, because the rules for multiplying fractions is top, bottom. So we would multiply this 2 times that 1 and put the 2 on top. And the 1 that's underneath that 2, the denominator on all whole numbers, we would multiply that 1 times X and we would get it. So even though this is what you would hope to see, so that it's very clear that that's the A, this is what you're most likely to see, a 2 on top. Okay, this is where B is a number that's greater than 1. The multiplier out in front, or the coefficient of your X, that's your B. It is a 2, and that 2 is a number that's greater than 1. I'm going to show you when we jump over here to Desmos that even though they are different transformations, they're different parameters, again, you will not be able to tell the difference by looking at the graph. The result will be the same. And there's kind of some algebra behind that as well. So in other words, you can turn every one of these B's into an A.